I would like to call the next presenter, actually the last session of today. Mr. Daniel Pradipta Juniardi, with the title of a Study on the Potential Application of Water Hyacinth as an Organic Corrosion Inhibitor. He's from Swiss German University. Mr. Daniel?
Yes.
Okay, Mr. Daniel.
Okay, thank you, Pak Heri, for the opportunity.
Yes, please.
So, good afternoon to all the participants. I, Daniel, from Swiss German University, am going to present you about my recent research titled Study on the Potential Application of Water Hyacinth as an Organic Corrosion Inhibitor. So here's the overview of my presentation today. So we'll start from the background and then continue to its objectives, research method, results and discussion, and conclusion. As for the background, iron and alloy are the metals that commonly used in industrial and building purposes. Although those materials are known to have strong durability, however, they are still highly susceptible to corrosion. And one of the best effective methods to shield the metals from oxidation is by the use of inhibitors. Inorganic inhibitors such as phosphate, arsenates, chromates, and dichromates have been found effective as an inhibitor. However, due to their highly operating costs and dangerous environmental effects, they cannot always be used for inhibition purposes. Corrosion inhibitor safety and environmental issues have always been a global concern in industry, since the use of such inhibitors can cause reversible or irreversible damage to the organ system, for example, kidneys and livers. Therefore, in recent years, scientists have been focusing their research on the use of green inhibitors, which not only cost-effective but also environmentally safe. And some of the natural ingredients that previously have been tested as corrosion inhibitors, for example, cocoa leaves, aloe vera, tobacco leaves, and many more. And one of the many potential sources of green corrosion inhibitor can be found in water hyacinth. Water hyacinth, Eichhornia crassipes, is a floating aquatic plant species, and due to its ability to cover the whole river quickly, water hyacinth is considered as one of the worst aquatic plants in the world. And the production of water hyacinth exceeds 125 tons of weight over 100 meters squared. And it has also been shown that water hyacinth is a very promising weed with many applications, for example, biogas production, animal fodder, and fertilizer. And water hyacinth has been alleged to have potential to be used as green corrosion inhibitor because of the phenolic acids content in it. Therefore, the main objectives of this thesis, of this recent research, was to study the potential of water hyacinth extract as a green corrosion inhibitor. Other goals are also including to improve the inhibiting effect from water hyacinth extract by adding other substance into the solution, which in this case chem aerobic, and to observe the corrosion rate of still before and after the addition of inhibitor. So for the research method was divided into three main parts, which were literature review, sample preparation, and total phenolic content analysis, which were done in the laboratory, and visual observation and corrosion rate measurement, which were done from home. And the literature review part was more emphasized in exploring the natural ingredients that previously have been tested, and its component which may contribute to the inhibition efficiency. And then after that, the component of water hyacinth and gum arabic also been observed to see the similarity between water hyacinth and those plant extracts. And for the experiment in the laboratory was divided into three main stages, which were pre-extraction of water hyacinth, extraction with ethanol water solvent, and total phenolic content analysis with Pauline calcium method. And then the experiment from home was done in order to continue the process of collecting data by doing corrosion rate measurement and inhibition efficiency calculation. And during the experiment from home, due to the safety reason, the solvent used was water instead of ethanol water solvent. So here is the illustration of experiment from home. And now we've come to the part of result and discussion. So we got here the first results from literature review parts. As can be seen from the table here, various of natural ingredients that previously have been tested as corrosion inhibitors with its inhibition efficiency. Although this data could not be a benchmark to each other, since there might be differences in corrosive media, in types of metals, and in corrosion rate methods, but it is clear enough to see that the natural ingredients have potential to be applied on the metals as an inhibitor. And then on the table below, we can see that the component of each natural ingredients that is believed to contribute to the inhibitor efficiency: pyrrhizine with its alpha-vinine, cocoalis with its alkaloid, flavonoid, terpenoid, and saponins, grape pomace with mainly its flavonols, guavalis with its tannins, and aloe vera with its hemicellulose, tannins, vitamin E, and carotene. And we see now the phytochemicals in water hyacinth. Based on Jimmy's finding, water hyacinth contains tannins, flavonoids, and saponins. And Harborne also mentioned in his report that water hyacinth contain high number of cellulose, hemicellulose, and lignin. And Kurniawan, Izzati, Nurhayati, and Monsot GR also mentioned in their reports that the antioxidant activity of water hyacinth not only coming from phenolic content, but also coming from vitamin C, carotene, chlorophyll, and vitamin E. Therefore, by looking to each of the components, water hyacinth has a lot of similarity to the other plant extracts before. In other words, we can say that water hyacinth contains natural chemical ingredients that can contribute in inhibiting corrosion. And now for the corrosion rate measurement. So the first graph here you can see is the corrosion rate in water media after 48 hours of immersion. The first graph here, it can be seen that the metals that were treated with water hyacinth extract as an inhibitor underwent a slightly reduction in corrosion rate. Meanwhile, on the other hand, the use of gum arabic alone also has the ability to reduce the corrosion rate. And then on a second graph, you can see the comparison of corrosion rate in sodium chloride and tap water media after 48 hours of immersion. By comparing its inhibitor in two different solutions, both series displayed a similarity in pattern but not quite in value. As can be seen here, the use of 20 milliliter water hyacinth could reduce the corrosion rate greater than the use of 30 milliliter water hyacinth. In addition, the use of 20 milliliter water hyacinth plus 10% weight percent gum arabic showed the most promising result. Therefore, for the next experiment, in order to achieve greater reduction rate, the formulation will have a mixture of 20 milliliter water hyacinth in it. And then the next two graphs show the corrosion rate reduction in two different corrosive solutions after the addition of gum arabic. From both graphs here, it can be seen that the more concentration of gum arabic could contribute more to the corrosion rate reduction. And then on the second graph below, you can see that the metals that were immersed in hydrochloric acid media underwent a massive corrosion rate. However, the use of a corrosion inhibitor was also work well there, as it could reduce the corrosion rate significantly. And one that can be taken as conclusion for this slide is the higher concentration of gum arabic, the higher the level of corrosion reduction. And then the next slide is about the inhibition efficiency from the previous slide. After the immersion of 24 hours, the highest the inhibition efficiency of inhibitors in sodium chloride media was 72.77%, whilst in hydrochloric acid media was 66.68%. In both solutions, the highest inhibition efficiency was obtained by using the same inhibitor, which was a mixture of 20 milliliter water hyacinth plus 20% gum arabic. Therefore, in the next experiment, the inhibitor used was only 20 milliliter water hyacinth plus 20% of gum arabic. And the next conducted experiment was about the inhibition efficiency over time of immersion. As can be seen from the graph here, the time of immersion affect the inhibition efficiency. The highest efficiency of inhibitor in sodium chloride media was obtained after 4 days of immersion, and in hydrochloric acid media was obtained after 3 days of immersion. However, after reaching its peak, the inhibition efficiency was reduced over time. This was in accordance with previous researches that stated that the water hyacinth extract may undergo degradation in quality, which may affect the inhibition efficiency. And in conclusion, from the previous discussion before, we can now understand that water hyacinth contains tannins, flavonoids, lignin, vitamin E, keratin, and chlorophyll, which may contribute to the inhibition purposes. And it has also been proven that water hyacinth inhibitor can reduce corrosion rate up to 79.75% in sodium chloride media and 71.08% in hydrochloric acid media. And therefore, water hyacinth has indeed the potential to be used as green inhibitor. And so that's all from me. Thank you for your participation.
Thank you, Mr. Dandi, for your presentation. So I would like to invite questions from the participants. Yes, we have some questions here. First is from Mr. Eka Budiarto. Do you think it is economical to use this extract as inhibitor, considering the cost for making the extract? Will there be a side effect of using this extract? Can you respond?
Yeah, for the economical value, I think it's very beneficial for us since the availability of the source itself is widely available. And as we all know that water hyacinth is a weed that can disturb the view of a lake, for example, or river, and maybe disturbs also the ecosystem below them. And since so, I mean that we utilize a waste to be something that is useful. So I think it's very beneficial for us if we really can utilize this accordingly. So that's all.
Yes, we still have some questions. The second is from Ms. Sylvia Yusri. How to measure the corrosion rate in this research? Can you explain?
How to measure corrosion rate in what? Sorry. Oh, so in this research. So yeah,
how to measure the corrosion rate.
So I use the difference of mass between the metals before and after the immersion of the metals. So I can show you the formula to calculate the corrosion rate from here. Wait, I need to turn on. So this, I use the difference of initial mass and final mass of metals before and after the immersion.
Mr. Daniel? Hello? Okay. Can you hear me, Mr. Daniel?
Yeah.
Can you hear me?
Yes, that was the answer for how to calculate the corrosion rate by using the formula of this one.
Okay, that's the equation. All right, we have another question again from Dr. Eka Budiarto. How do you propose to apply the extract? Will you spread it on the metal, or do you have any other technique?
No, I just combine the inhibitors in form of liquid, and then I just put it down on the corrosive solution using for a certain concentration.
Okay, okay then. So Mr. Daniel, the last question is from me. What do you think? Let's say the weakness of this result. Therefore, the further research can fix it or can make it more perfect to be continued to more to the application. Is there anything
Well,
that you
since
think can be improved?
well, since this research was done from home with the equipment that is not complete, I mean the equipment are not complete, and so we can make it more perfect and more reliable by doing it in the laboratory. For example, we can extract it with the real solvent, which was ethanol and water, with the comparison 1-to-1, and then we can try to apply it on different types of metals, as well in the different types of corrosive media, and maybe for the visual observation we can use a microscope to see the surface more clearly.
Okay, Mr. Daniel, thank you for your answers, your response.